All right, geometry, here's your second lesson. So this is composite figures, and basically what that means is composite means it may be made of different shapes, and that's what it looks like in geometry. Now in real life, if you take a look at composite wood, that would just end up being like particle board all kind of pushed together with glue and pressure. A lot of countertops are made out of composite wood. It's that wood that over time when water gets on it, it starts to flake away, or like plywood. Another real life application is music, because if we have a composition of a whole bunch of musical pieces, or in this case, if you think about what music is, it's just a bunch of notes strung together and it creates a melody. And so the notes themselves are each part. And when we're talking about geometry, our composition of different figures is, one of them is a rectangle, and in this case, here's our trapezoid. So what we're going to do first is a composition figure is a figure that can be separated into regions or shapes that are basic plane figures like triangles, parallelograms, trapezoids, rectangles, circles. Okay, to find the area of composite figures, we need to divide up the regions. So we're just going to draw that out, 1 and 2, so label them. Okay, and we're going to find the area of each one, and then all we have to do is add them together. So let's go ahead and take a look at directions for number 1. Okay, and by the way, on this video, you can pause it at any time and work the problems out on for yourself, and then go back and review the video just to see if you're on the right track. Okay, there will also be an answer key attached to this lesson at the end, so you will also see that. You do have to make sure you do the reflection questions. That is what I'm showing or seeing how you understand this concept. Okay, so for number 1, we have 2 shapes. One of them is a rectangle, and the other one is a trapezoid, so I'm going to go ahead and put that shape over here. And what we're going to do is we're going to first find the area of a rectangle first. So that area is, looking back at your formulas, which I hope you guys don't really need for some of them, but here's our rectangle formula. So area equals length times width. So if I take the length and the width for this area, it would end up being 23 and 12, because that's the length of this side here. So we'd end up with 23 times 12. That would be the area for the rectangle, which in that case is going to end up being area equals 276 centimeters squared. Now for our trapezoid, we're going to start off with our trapezoid formula, which is going to be area equals 1/2 times the height times the sum of the bases. So here we are. So we have the area equals 1/2 times the height, which we do not have. We need to find the height of this trapezoid. And the way that we're going to do that is we're going to actually take a look at this entire length, which is 18. And they gave us one side length to the rectangle, which is 12. And we're going to go ahead and subtract, which is going to give us just a height of 6 centimeters. Okay, so I know that the height is 6 centimeters times, okay, the sum of the 2 bases, which we don't have a length here, but since it's a rectangle, opposite sides are congruent. So we would be left with 23 and 15. So 23 plus 15, okay? And we're going to go ahead and calculate that out. It's going to be 114 centimeters squared. So that's the area of the trapezoid. And when we add those two together, so the area of the entire figure is going to be 276 plus 114 centimeters squared, which is just going to equal 390 centimeters squared. All right, let's go ahead and take a look at number 2. Number 2 is a little different because I noticed that there is a semicircle here and another semicircle here. So if I have 2 semicircles and I put them together, I would just end up with one large circle. So that's going to be my first shape. Okay, one shape together. Now the next one is going to end up being the parallelogram attaching those 2 semicircles. Okay, so I'm going to start off by writing down my formulas. So the area of a circle, I know, is area equals pi r squared. So I need a radius, okay, but we'll get to that in a minute. The area of a parallelogram is the length times the width, okay, whoops, length times width, or base times height. Okay, so in this case, we do have a base. Well, we have a radius of the circle. From the middle of the circle out is 6 inches, so this has to be 6 inches here. So for the entire distance, it's going to be 12. Okay, so that's going to be the base perpendicular to the height. So we're going to end up with area equals 5 times 12. And then on this, for the circle, we would end up with the area equals pi, which I'm going to approximate to 3.14 times the radius, which is 6 squared. Alright, 6 squared is just 36. Okay, and then 36 times pi, or 3.14, is going to give me 113.1. Okay, and that's approximate because of pi. And so that's the area of the circle. Over here we have 5 times 12, which is just going to give us 60. So the total area equals 113 plus 60, which is going to give us total of 173.1 inches squared. Okay, so for number 3, this one's a little different because we have 3 shapes put together, 3 composite shapes. So we have to go ahead and take a look and see how we can break this apart. So we have 1 shape, 2 shapes, and the 3rd shape, which is a semicircle. So for our first shape, it's a rectangle. So the area is just going to end up being base times height, which the base here could be either 2 of those. Either this one or this one, but we only want to take a look at the shape itself. Okay, now we're not given some information, so we have to figure out some of it. But notice how with a rectangle, opposite sides of a rectangle are congruent. So using that property, I know that the radius of the semicircle is 9. If I know that the radius of that semicircle is 9, then I also know that this is 9 over here. This entire distance is 18, but I don't think I'll need that. Okay. Okay, oh, I see it. Alright, I'm going to add it in a different color. This part right here is 9. So if I know that this is 9 and I have the entire distance, okay, is 26, I can subtract 26 minus 9, which would just give me 17. So this distance for the rectangle is only 17, and this is 9. Okay, so what we're going to do next is we're going to go ahead and I'm going to go back to blue just for the rectangle, and then I'll change colors. So we have our base, which in this case can be 17 times 9, so the area of the rectangle is just going to give us 153 feet squared. Okay. Now for the second shape, we do have a triangle. Area of a triangle is area equals 1/2 base times height. So we need the height. Whoops, let me change colors. Let's go to pink. We're going to take a look at this triangle right here. They don't give us a lot of information, except for the fact that I already found that side length is 9. Okay, I do know that this length right here is 17, and if this is 7, what's 17 minus 7? That's going to give us 10. So that length is 10, and we do end up having our height and our base. So our area is going to end up being 1/2 times the base, which is 9, times 10. Okay, 9 times 10 is 90, divided by 2 would just give us 45, and that's going to be 45 feet squared for the area of that triangle. let's go ahead and take a look at the next one, which I'm going to do in, I'm going to go for gray. The next one is a semicircle, and we do have from here out, it's just going to be 9 as our radius. I need the area of a circle, which if you keep your paper from the last lesson, you can go ahead and take a look. It's going to be area equals pi r squared. Okay, so we have area equals pi r squared, and we know that the radius is 9. But remember, we do not need the whole circle, we just need half of it. So our formula is going to be completely divided by 2. So we end up with our area equals pi, which we're going to approximate to 3.14, times our radius, which is 9 squared, divided by 2. Alright, so we have 81 times 3.14 divided by 2, and that's going to end up being 127. Okay, 127.23 feet squared. Okay, so ultimately what we're going to do next is we're going to add all of those numbers together. So to find the total area, it would be 153 plus 45 plus 127.23 feet squared, which is going to give us a total, oops, I'm going to do that at the end, which is going to give us a total area of 325.23 feet squared. Okay. All right, let's go ahead and take a look at this ice cream cone. Okay. So with this problem, we're going to go ahead and start off by breaking it apart into two shapes. So we have 1 and 2. I see a half circle or a half semicircle, and I also see a triangle, kind of isosceles triangle, which is kind of cool. We can break that apart and make, because remember with we need a height and we need a base, so 16 is going to end up being our base here. Let's go ahead and start working on this circle though. Okay, so the diameter equals 16. We know that the area equals pi r squared, so in order to find our radius, all that we have to do is take half of our diameter. So half of our diameter is 16 divided by 2, which is just going to give us 8. So then we're going to end up with 8 squared, which is 64 times 3.14, okay, and that's going to give us a total of 100.53 meters squared for the area of that semicircle. So when we're looking at the triangle, okay, we're going to start off with finding the height. We don't know that. So if we don't know something and we have a triangle here, we do know the hypotenuse, this length, because from here out is the radius, so that's 8. We can use the Pythagorean theorem to find the length of the height, or the third side here. Okay, so what we're going to do is we're going to start off with 8 squared, because that's a leg length, okay, plus we don't know what that height is, so I'm going to label it x, equals 17 squared. Okay, so it's going to end up being, we can go ahead and simplify this out. We end up with 64 plus x squared equals, and then we end up with 17 squared, which is 289. So subtract 64 and then square root 225, which is just going to give us x equals 15. Alright, so that's our total height here, and we're going to substitute that back in. So the area formula is 1/2 base times height, and that's going to end up being 1/2 times 16 times our height, which is 15. Okay, and our overall area is going to end up being 120 meters squared for the inside of that triangle. Alright, so we're going to add all of that together, and we're going to end up with our total area of 220.53 meters squared, and that's going to be the total area for that shape. Okay, alright, I'm going to go ahead and finish this video off, and we're going to stop here, and we'll pick up on number 5 for the next video. Thank you. Bye.